Now let's look at the next example. This example uses dictionary. Dictionary. And let's look at the first one here. First of all, it creates a object called a sorted dictionary. This is a generic class. Sorted dictionary represents a collection of key and value pairs that are sorted on the key. Dictionary and hash table are very similar, but dictionary operates much faster than the hash table, because dictionary put a key in the binary search tree. We have talked about the binary search tree in the previous example, because binary search tree can return the result much faster. That's why we say dictionary operates or process data faster than the hash table, and the dictionary is a generic type. That means you can put any data type into the dictionary, but hash table is not a generic type. So right here, this dictionary specified the key, the string, the value must be integer, but it could be any type. It could be any type, and the result, the object is returned, is initialized by calling collect words, and display dictionary by calling dictionary after the dictionary is created. Now let's look at a collect word method, which is right here. Inside, create a sorted dictionary with a string as the key and an integer as the value, and call constructor to initialize the object dictionary. And then enter a string. I entered a string right here. How are you? That's what I entered right here. And after the string is entered, then same thing as what we did before. It was put into an array words, and use the for loop to cycle through the array, change everything to lowercase, and then if dictionary contains the key, then it increased the dictionary value plus. That's increment, because of the integer we talk about is created as integer, so the value is increased by 1. And else it just add the key and the value into the dictionary using method add an element with the specified key and value into the dictionary, sorted dictionary. Because the notice here we're calling, it's called a sorted dictionary, means anytime you enter the key and value into the dictionary, it is sorted automatically. The algorithm for sorting is binary search tree. And method display dictionary, same thing. It has two as k and v, and this is the generic class. And inside here, just say sorted dictionary, and then use for loop to go through the dictionary based on the keys, and then display the key and the dictionary value. That's why we got this result here. And you can see this result is almost the same as what we did before at the hash table. And I'm gonna run this again, and then this time I'll enter redundant value, say AB, CD, MM, KK. So I'm gonna hit enter. You can see AB got a 2 value 2, and KK got a 3, because and also notice here it is sorted in ascending order. The keys are sorted in ascending order when it's printed out, and because we just accumulate the value by increasing the value. If the same key already exists, then it doesn't add a key. It does not add a key to the dictionary. Instead, it add a value, increase the value for that key. Otherwise, it's add a key, add a key and add a value 1 to the dictionary. This is the dictionary, and the difference of hash. This is the Microsoft website MSDN, and explains the difference between the dictionary and hash table. And hash table is a dictionary is much faster than the hash table. That's why I say most people use dictionary instead of using the hash table. But the good thing about the hash table is it is thread safe. It is thread safe. So if you are doing the multi-threading or something similar, then the dictionary helps you. Now let's look at the next example. In this example, linked list test. This is the static read-only string array with these elements. The second one is still read-only string array with these elements. In method main, this is the object linked list. Linked list is a doubly linked list. With linked list, we can navigate the list both backward and forward with nodes of generic list. Linked list means we can move both directions, move forward and move backward. Each node in the linked list contains property value and read-only properties previous, next. The value properties type matches linked list single type parameter because it contains the data stored in the node. Previous property gets a reference to the preceding node in the linked list. Next property gets a reference to the subsequent reference in the linked list. Now let's look at the code. So that creates the linked list, and then there's a for each loop to cycle through array colors using method add last to add a new node containing the specified value at the end of the linked list. So the method is called add last. Add it to the end of the list. And in our case here, each color is added from colors. So these values are added to the list. And list 2 is initialized by colors 2. So this list 2 is linked list, and the values in the linked list are these values. So we have list 1, list 2. Now method concatenate with two parameters, list 1, list 2. Let's look at the definition of concatenate method. This is the concatenate method. Concatenate. Now notice here is a generic type method, and it has two parameters: linked list, list 1, linked list, list 2. Inside there's a for loop. Go through list 2, add each item of list 2 to the list 1 using add list. Same thing, add a new node containing the specified value at the end of the list. That's how each value of list 2 is added to the end of the list 1. So that's how this list 1 and list 2 are concatenated together. So list 1 is appended. List 2 is appended to list 1. So after this call, list 2 is added to the end of list 1. And you can see that when it says print list, method print list 1. These are printed. And method print list, let's look at a method print list. This is the print list. It's actually just a for loop, for each loop. So go through the list 1 and then print each value. Then we get these values right here. Now let's go back to method. Uppercase to uppercase string list 1. Now let's look at the method to uppercase string list 1. So to uppercase is right here, and it takes one parameter linked list, and inside of the method it creates a linked list node. Linked list library class linked list node is a generic class. It represents a node in the linked list. Remember, this time we don't. The element in the linked list is called a node, and it creates one node. The object node object passed the first node from the list into list first is the property. It gets the first node from the linked list. So the first node is retrieved and passed to the current node. And we know that the first node is black, right? That's the one we're talking about here. So this one is right here. It passed to the first node to the linked list node object. If the current node is not null, because it's an object, if it's not null, then the value of the node is retrieved. Value here gets the value contained in the node and put into string variable color, and then call string method to upper to convert it to uppercase. And this is a while loop, so it cycles through the loop until the end of the linked list. And once it reaches the end of the linked list, the next node is not available, so it's null. Then the loop will stop. And that's how each element or each node value is converted to uppercase. And then call print list again. Then we get everybody in uppercase. And next line, deleting string black and black. So deleting, that's the message we see right here from here. And then what it does is called remove item between. So remove item from the list from between black and brown. Now let's look at the method remove item between. This is the remove item between. It takes two parameters, linked list and start item, end item. Inside it create two list node, current node, last node, and using method of find from the linked list, finds the first node that contains the specified value. So right here we say start item, find this item, and then find this item. So put save it into current node and end node, and then use a while loop. So while current node next not equal to null, means it will go through from the beginning to the end. Once it reaches the end, then the null will be returned to the next method. If it's not a null, end is not equal to end node, then it called remove. Remove current node next. So because it starts from the current node, because we tell that we start from this node, so start from the current node, and then it say remove next. The current node will not be removed, but it removes the next one until it finds the next node, or it reaches the end of the node, the end of the list, then it stops. So after it's removed, call print again, and we see that. We see those. Notice here the black is still there because it says when it removes the node, it moves to the next. Right here, next gets next node means the current node is not removed because the current node is passed right here. So it's black. It's not removed. It only removes the next node. So after either it reaches the end of the list or it reaches brown, then it'll stop. So that's why we have this list right here. And because those two nodes are passed here, let's say black and the brown. And our list is right here. We have a black, yellow, green, silver, and then gold, white, brown, blue, gray. So after remove item between black and brown, then all of these, see this is black is reserved, and all of these are removed. The only 4 colors left: black, brown, blue, gray. And that's how we see black, brown, blue, gray right here. And then the last method to run is called print reverse. And here's our method print reverse. Print reverse, create a node again, link the list node again, and then all it does is it's called method previous. Get a previous node. And when this list is created, it starts from the last node, because right here list.last gets the last node of the linked list. So it goes backward using previous and put a last one and get a last one, then go the previous one, go previous one, go. That's why when it's printed out, then we get a gray, whatever was last, now that becomes first one, and blue, which is this one, becomes second one, and brown and black.